Hello guys, I am Arvind and this is continuation video of Numpy and it is part 9. Guys, we are discussing Numpy operations. So in this lecture, we will learn how to use Numpy standard deviation function, or we can say np.std. So before we get into the details of Numpy standard deviation function, let's discuss what standard deviation is. So guys, standard deviation is a measure of the spread of a dataset, or we can say the array elements. We can also explain standard deviation at a very high level. We need to find out the mean of the datasets and then we'll find out how much each element deviates from that mean, and that number is known as standard deviation. So guys, now let's go ahead and we'll discuss Numpy standard deviation function. So guys, Numpy standard deviation function computes the standard deviation of the given data, or we can say array elements, along the specified axis. Now let's go ahead and we'll discuss the syntax of this function. So here is the syntax of this function. And there are several parameters that allow you to control exactly how this function works. So let's take a look at each of them. So the first parameter is array. The array parameter specifies the input array of elements to the function over which you want to calculate the standard deviation, and it is required parameter in the standard deviation function. Now let's go ahead and we'll discuss next parameter, and that is axis. Now guys, the axis parameter specifies an axis along which the standard deviation will be computed. Otherwise, it will consider array to be flattened, means it works on all the axes, and it is an optional parameter. And guys, if we set axis equals to 0, then we want to calculate standard deviation along the columns. Remember, axis 0 refers to the column axis. Similarly, if we set axis equals to 1, then we want to calculate standard deviation along the rows. Remember, axis 1 refers to the row axis. Now moving on to next topic, and that is D type. The D type parameter specifies the data type that you want to use when standard deviation function calculates the standard deviation, and it is also an optional parameter. If the data in the input array are integers, then this will default to float 64, and if the data in the input array are floats, then this will default to the same float type as the input array. Now moving on to next parameter, and that is keep dims. So when you set keep dims equals to true, then output will have the same number of dimensions as the input, and it is also an optional parameter. So for example, if we are using a two-dimensional array as an input to standard deviation function, then output will be a number, a scalar value. Actually, standard deviation function or std function collapses the number of dimensions. But if we want output of the same dimensions as the input, then we need to set keep dims equals to true. Now moving on to next parameter, and that is out, and the output parameter specify an alternative array in which to put the output by the standard deviation function, and it should have the same shape as the expected output, and it is also an optional parameter. Now moving on to next parameter, and that is DDOF. This enables you to specify the degrees of freedom for the calculation. So the divisor used in calculation is n minus DDOF, where n represents the number of elements. By default, DDOF is 0, and it is also an optional parameter. So guys, now let me open up the Jupyter notebook. So guys, now we are going to use Numpy standard deviation function on one-dimensional array. So let's create a one-dimensional array. So guys, I have created a one-dimensional array, and that is assigned to A, and now I am going to print this A. And now if I run this script, it will give you the one-dimensional array as output. And now guys, we are going to apply numpy standard deviation function on this one-dimensional array. So guys, I have passed this array A to this standard deviation function and I am printing this. Now if I run this script, it will give you the standard deviation, and that is 1.4142 and so on. And now guys, I am going to use this standard deviation function on two-dimensional array. So let's create two-dimensional array. So guys, I have created a two-dimensional array of 3 cross 3. So let's print it. Now if I run this script, it will give you the output like this. And now I am going to apply this standard deviation function on this 3 cross 3 matrix B. Now if I run this script, it will give you the standard deviation, that is 2.5819 and so on. Now guys, I am going to use optional parameter, and that is axis. So let's add axis, and I am assigning 0 to it. So basically I want to calculate standard deviation along with the columns. So now if I run this script, it will give you the standard deviation along with the columns. Now if I change 1 and run this script, then I am getting the standard deviation along with the rows. So I hope it is clear to you guys. Now if I add one more parameter to it, and that is d type. So as we know guys, if the data in the input array are integers, then output will be in float 64. So by default it is giving float 64 data. And if I set float to it and run this script, so basically it will give you float type of data. Now guys, I am adding one more parameter to this function. So let's add keep dims. And I am assigning true to it. Now if I run this script, it will give you the standard deviation along with the rows in the two-dimensional array. So I hope it is clear to you guys, and thank you so much guys for watching this video. Just in case you liked it, do not forget to like and subscribe. I will see you then in the next video.